Hey everyone, welcome. I was pleasantly surprised because StreamYard changed that 30-second countdown music. It was very different for the last 3 years, and they've added like a new, very catchy track. I noticed both of us were like bobbing our heads to the track when it was playing.
Yep.
Yeah. Friends, for those of y'all who have joined us for the first time, this is our fortnightly stream. We call it office hours because it is informal. You can ask us questions, and we usually talk about like some topic. My name is Sohan Maheshwar. I'm a dev advocate at AuthZ, and Tanner is joining us today. Tanner, welcome to the stream.
Thanks for having me.
Yeah, and I see some familiar names in the audience today. We have Yordis, Evan. Hey, folks, thanks for joining in. Folks, let us know where you're streaming from or where you're watching us stream from, rather. I'm in Amsterdam where it is raining, but that part of the weather update can be, I think, fairly common, given that it rains here all the time. Tanner, you're in the Colorado,
I'm
I
in
think, somewhere?
Colorado, yeah.
Yeah, cool. All right. So, folks, today we are going to be talking about the dual write problem. Now, if you're interested in things like distributed systems, this one, you're going to enjoy this one. Tanner's already, prepared like a bit of a presentation and things. So let's dive straight in. Let me just
Cool.
share your screen, Tanner. Yeah.
Sounds good. Yeah, all right, let's get into it. So this is the dual write problem. And the idea is that like I'm going to talk through some slides. It's going to be pretty much the same content as the blog post that I wrote, but it's going to be a little more visual. We'll go into a little more depth. And of course, y'all are able to ask me questions and we can kind of get into more of the details here. So starting off, what is the dual write problem? To kind of like set the stage and explain it, we're going to go into an example application. So let's say we're working on a Dropbox clone. And the idea is that you can upload files, you can organize them into folders, and then you can share them with other people. And we're going to keep it pretty simple to start. And you're working on the upload endpoint. So we have an endpoint that validates the request. This is where like any authorization logic happens, any like structural validation. We open a transaction with our database, and then we write a file to that database. Then we return a response. That's easy. That's great. But we have an idea in our heads that we want to use SpiceDB to do the authorization logic on this. And that's because you know that as things are like, as the application develops, you're going to split things out into microservices. The idea of centralizing authorization logic seems appealing. So we're going to figure out how to bring it in. And so we start by adding a relatively simple schema. We've got a user, which is our subject. We have a folder, which is containing files. And you can say that a user is a viewer of a folder. And then we also have files, and users can be viewers of files. And the thing to notice here is that files are connected to folders. And the idea is that if you can view a folder, then you can view all of its contents. In a more sort of visual way of representing it, you might have like a pictures folder and a trip folder, and then you have pictures inside of that trip folder. And the idea is that someone who's a viewer of the trip folder can see all of the pictures within it. Any questions there so far?
No questions in the chat, but I have a question again, just to set the context. So suppose I add another trip, like say a trip to Santa Barbara, because someone mentioned in the chat. So
Yeah.
then automatically people will be able to see all the photos in that folder as well, correct?
Only if they are set as a viewer of that folder. If you set someone as a viewer of the pictures folder, then yes, they would be able to see everything in all descendants. Well, actually, not as the schema is currently written. It's flat at the front.
Okay, yeah.
But not important for our use case, so we'll keep rolling with it. So this is kind of our first iteration of that logic. We open a transaction, we write our file to the database, and then we write the folder relationship to SpiceDB. So we're writing a relationship between the file and the folder. And then we return a response. And this looks fine. This is simple. This is easy. But there's a problem here, and it's the dual write problem. So to illustrate what I'm talking about, we're going to talk about some different points in the code. So the thing to note here is that when I'm talking about point one, I'm not talking about the line of code that's underneath it. I'm talking about the space in between these two statements. So point one is in between request validation and opening a transaction. Point two is in between writing the file to the database and writing the folder. And point three is we're saying it's still inside the transaction, as in the transaction has not been committed yet, whereas point four is outside of this transaction. Here's another sort of visual representation of it as the stream diagram. So clients on the left, we have the handler code in the middle. This is like the sort of top level of our request handler. And then we have inside the transaction. So point one is in between validating the request and starting the transaction. Point two is in between writing the file to the database and writing the relation to SpiceDB. Point three is in between writing the relation to SpiceDB and closing the transaction. And then point four is after we've committed the transaction. So all of that to set the table. The thing that we're going to talk about is what happens if the server crashes. And server crashes are nice because it's a simple thing that can happen to any system, and they're also really hard to recover from. You can't really try catch around a server crash. So what happens if the server crashes at each of these points? If we crash at point one, we haven't started doing any work. So the gateway will return a 503. Nothing's happened, we're fine. If the server crashes at point four, we're similarly okay because it's after the transaction is committed and we have written to both SpiceDB and the database. Even though we get a 503 that's an error, the data is in there, everything's consistent, we're okay. Point two is okay too, because we've opened the transaction and we've stated our intent to write a file to the transaction, but we haven't closed the transaction yet, which means that when the server crashes, things will 503, the connection to the database will disappear. Your data store is going to roll back that transaction or just never committed in the first place. And we haven't written to SpiceDB, so everything is still in a consistent state. But point three is the problem. And the reason for that is that we have stated our intent to write to the database, and we've written the relation to SpiceDB. And to review, when you make a write relationships call to SpiceDB, it's an atomic operation. Everything happens at once. It's committed to SpiceDB when you get the response back from the gRPC call. But we've written to SpiceDB and the transaction is still open. If the server crashes right here, then your data store is going to treat the transaction as still open. It's never going to commit it. So we've written to SpiceDB, but we haven't written to our application database. And that means that we're in an inconsistent state. And that's a problem. And this is basically the dual write problem. It's that you've written to one, but you haven't written to the other, and you can't really know what state you're in by just looking within the handler code. And there are some things that might seem like obvious ways to mitigate this. What happens if we reverse the order with which we're writing the file to the database and writing the relation to SpiceDB? If we reverse them, then you can still have the issue of you've written a relation to SpiceDB. Oh.
No, I think you'll have a very similar problem, right?
Yeah, exactly.
Yeah.
And then we've also had people ask about well, what if SpiceDB had a transaction semantic? What if it was that you could prepare a call to SpiceDB and then you could send a commit message that says, all right, I'm good. I want to actually commit this to SpiceDB. And that doesn't really change things because you still have two commit calls that you need to make. And if one of those lands and the other one doesn't, then you still have an inconsistency. And as it turns out, this is just a hard problem. It's reducible to the Byzantine generals problem, if you remember that from a comp sci class. And the idea is that if you have a bunch of generals who are sitting around a city and they all need to attack at the same time, and the attack only works if all of them attack at the same time, it fails otherwise. There isn't a way from the perspective of a general to know for sure that all of the other generals are going to attack at a specific time. Us sitting here looking at the operation from like the top view, like as a sort of outside observer, we could see whether things are correlated or not, but the generals themselves can't. And that's sort of analogous to like the handler itself can't. There are ways that you can mitigate this issue by doing more work, but you can never get rid of this issue entirely. And the thing that I want to call out here is that this is a feature of every distributed system. We're talking about a handler that writes to an application database into SpiceDB, but there is nothing special about like an application DB in SpiceDB. There's nothing special about SpiceDB in this case. You're going to have this problem if you're in a microservice architecture and you need to write something to one service and write to another service. You would have this problem if you were writing to a cache and an application database. You usually don't care as much about caches because it's a cache, but this problem is present there. Anytime that you're trying to write to two different systems, you've got this problem. So yeah, I guess pause for questions there.
Yes. Yep. Yordis wants Python with brackets. Come on, Yordis.
Oh yeah, that's entirely fair. I reached for Python because it's readable, but I didn't consider that like nesting is the problem there.
Yeah, but it's okay. He's brought out the ruler to check the indentation, so we're good.
Yeah, for sure.
Yeah. And folks, again, if this is the first time you're checking out our live streams, feel free to drop in any questions or comments you might have in the chat, and the point is for us to answer them. And so don't hesitate. Dana, go ahead.
Cool. So given that this is a problem that's really hard to solve, let's talk about what we can do. What do we do? One answer is nothing. And this may seem counterintuitive, but depending on your system, this might be a sane response. All of the other things that I'm going to describe are adding additional complexity to your system. They're adding additional points of failure. They're adding additional like developer overhead in terms of the things that they have to think about and pay attention to. So if your system would be okay with it, then doing nothing is an option. And there are some characteristics of a system that I would say make it more amenable to doing nothing. One is having a simpler system and a simpler schema. Another is having like a very reliable system, one that doesn't go down very often, one that doesn't have faults very often. There's like, if your data isn't particularly sensitive, if your users aren't particularly sensitive to like not being able to see something that they should, or vice versa, if the system is one where people are going to notice problems quickly and fix them quickly, then that could be a place where this is potentially okay. But it's ultimately going to come down to your business case and like any compliance issues that you might have and things like that. So, it's an option.
It's an option. My favorite option, like doing nothing, just letting it be. But yeah, it depends on your use case, I guess.
Yeah, and to Yordis's point, like the waking up at 3 a.m. to fix data integrity, been there, done that, don't want to do it again. So we'll talk about some other approaches here.
Yeah.
So another one is out of band consistency checking. And the idea here is that you don't try and solve the dual write problem directly. You still just have your application writing to one place and writing to another place. But then somewhere outside of the system, you have like something that's on a cron job, something that's on a timer that goes through and it makes sure like it tries to look at what's in SpiceDB, what's in your app database, and tries to see whether they agree with each other. And with our particular example, what you might be doing is making a read relationships call to SpiceDB to say, hey, give me all of the like file folder relationships. And then you would make a call to your application database and you would say, hey, give me all of the files, and I'm going to look at the foreign key to the folder. And you're just going to go through all of those and make sure that they agree with each other. If you're doing this periodically, you can flag that for manual review. You can do some sort of automated annealing process. And the idea here is that you would get some information about whether your system has problems. There are problems with this approach. One is that you don't necessarily know when a write is going to land in one database versus the other. And so you may have false positives just because something has showed up in one place but not another. You can try and approach that by like getting a specific snapshot of SpiceDB and making a read to your application database that's like for a point in time, or you've locked your application database while you're making these reads, but then that slows down throughput. It's something that is probably only going to work well for simple use cases and relatively small scale. As things get bigger, as the velocity of data grows, this is going to become more and more difficult to do reliably.
We do have a couple of questions. Yeah, Dana. So one is, I think Yordis's question, right? Like, do people actually do this in the real world? Because it sounds like a lot of work.
Well, like, concrete example, at my old company, we used SpiceDB, and I have a coworker who's still there who I talk to periodically, and he said that they are considering doing something like this because they've had 2 or 3 incidents now where it seemed like 2 systems ended up out of sync. And so just wanting to have some signal of whether there's something going on there. I think that for them, it's probably going to be a flag for manual review thing, but yeah, it is a lot of work and it's not fun. So there are other approaches that would work around this.
Which we're going to talk as well about some of the other approaches. We have a question from Andre, who I think is also Andre from our Discord, I assume. Hi, Andre. Thanks for joining in. Do you consider storing relationship folder viewer only in SpiceDB or also in the app database?
Wait, that's actually the next one that we'll talk about. So that's a nice segue.
Thanks, Scott, for joining in.
Yeah. So this, like, another approach would be to use SpiceDB as the source of truth. And the idea here is that on the left is like the old state of the system, and on the right is the new state of the system. You have your API handler talking to your application database, and then you say, okay, we're just going to like move everything over to SpiceDB. And the application is only going to talk to SpiceDB for this particular piece of data. And the nice thing here is that because you have replaced one database with the other, rather than writing to both of them, you get rid of the dual write problem as an issue here because you aren't writing to 2 things. It's only going to work for some use cases, though, because SpiceDB is an authorization database. It is highly optimized to answer questions about whether a subject has a permission on an object. And as such, the way that it's constructed isn't amenable to some general purpose, like normal things that you would do with a general purpose database, namely sorting, filtering, and pagination. It doesn't have the information required. It wouldn't be performant. So that's not an option that you have. And so it's really going to depend, like, whether this is going to work for your use case is really going to depend on what UIs this needs to drive. If it is like, if your UI and the things that your UI needs to do are amenable to this approach, then like, great, that works great. But like an example for, if we're talking about this folder, this file and folder example, you can pretty easily list out the files associated with a given folder, but you aren't necessarily going to have a stable ordering of those. There isn't a good place to store metadata about the files, so you would still need another database for that, and then we're back into dual write territory. And like the pagination, there is cursored pagination available on lookup resources and on read relationships, but we don't do limit offset pagination. So some UIs, like a UI that shows you like a pagination interface at the bottom that's like 1 to n, that's not going to work because you don't actually know how many pages you have. So it's going to depend on the use case. If it matches, this can be a good way to go. It's a very simple way of thinking about the problem, but it's not always going to match. Yeah, Yoda's exactly. Who needs users?
Who needs it?
Yeah. All right. So yeah, this is one way of thinking about the problem, but we'll move on from here to the more complicated approaches that are, theoretically more robust, but also bring a whole lot more complexity. All 3 of these next few, all three of these that I'm going to talk about are under the umbrella of what I would call eventual consistency. you're making a trade-off between knowing that your system is going to end up in a consistent state and being able to get a synchronous response out of your system of like what the current state of the system is like after a write. And this, like what I'll talk about first, is a sort of event sourcing approach. And then we'll also talk about durable execution environments and about a transactional outbox approach. So a way that you can work around the dual write problem is using a durable queue. This is like, you've got a queue, it's Kafka, it's Nats, it's RabbitMQ, it's Red Panda, it's something like that. And the idea is that you separate the writes from the reads. You'll hear this talked about as command query responsibility segregation. And the idea is that your reads and your checks are queries, and they go through one path, and then your writes are your commands, and those go through a different path. So reads for data go directly to the application database, checks go directly to SpiceDB. But when you make a write, the application just puts a message on the queue. And so in our case, this would be like a creates file message. And that message is going to include everything that a downstream consumer would need to know about the file. And then there are listeners on that queue that take the event and they write it into their database according to the needs of whatever their particular database is. So one listener is going to write a relation between the folder and the file, and the other one is just going to take the information about the file and store it in the application database. Everyone with me so far?
Yeah, I think so.
Okay. So the nice thing here is that the use of this durable queue means that as soon as the write lands in the queue, you know that at some point in the future, your system is going to be fine, because like the queue can go down and it'll come back up and it'll still have the data in it. The listener can go down, it'll come back up, it'll start reading where it left off and doing the work. SpiceDB can go down and the listener will just kind of hang out and wait until SpiceDB is back up. But you know that when you have written something to this queue, it'll eventually show up in SpiceDB. It'll eventually show up in your application database. That's the name of the game with eventual consistency. And the idea is that because you're only making a single write to the queue, we don't have the dual write problem anymore. But as you can see, there's a whole lot of additional complexity here. It's a lot of additional infrastructure. It's a lot of additional sort of overhead in terms of what the developer needs to be aware of. And the biggest reason for that comes down to like what happens in your UI. How do you think about making a write in this system? Because you'll notice that like if you just have a system that looks like this, the only thing that the application can tell me when I call the API to say, hey, I want to create this file, is it's really only going to be able to say, hey, I have written the message to the queue and I have acknowledged the thing that you've sent me. But I don't know necessarily when it's going to land in the application database or in SpiceDB. I'm not going to necessarily know when I can make a read for that same information and have it show up and be reflected. Obviously, like ideally, it's going to happen in like a handful of milliseconds because the throughput of these systems is really pretty impressive. But like if there are faults in any part of the system, I might not be able to see that. If there's a slowdown in any part of the system, I might not be able to see that. And like it kind of violates a user assumption that like, well, I've created the thing, where is it now? And there are ways of working around those problems, but they entail additional complexity as well. Like, oh, hello. So one way that you could think about doing this is, okay, what if we added more queues to the picture? When in the application API handler, when we make a write, we start waiting. And then we're looking for a message that comes out of an output queue that corresponds to the message that we wrote to the input queue. Use some sort of like request ID correlating identifier or something like that. And then what you do is this listener that writes to the application database, when it's done, it would write to some output queue. Same thing with the SpiceDB one. Somewhere downstream, you've got logic that correlates the two output queues from the two systems that are writing and matches up a request and says, okay, all of the work has been done that's been associated with this request. And then it can write to an output queue that the application is listening to, and you've like sort of blocked until the entire system is done and ready. But you can hear the number of hops in there. That's a whole lot of places for things to go wrong and for things to slow down. So you're introducing a good amount of additional latency and like a number of additional fault points for the request response part of your application. So maybe that works for your system, maybe it doesn't. Another way of thinking about the problem is really going like a full event sourcing approach. And the idea there is that...
One question, Tana, sorry for interrupting. So again, just from pure semantics, and I think Yordis is asking this as well, like this first approach, is that like a purely message streaming thing, or are we doing event sourcing here as well? Or is the second approach more like event sourcing? I think Yordis had the same question.
Yeah, it's a good question. I'm kind of like iteratively building towards the thing that I would describe as full event sourcing. And that's like the next thing that I would talk about as far as like how the UI would know something about what just happened. So let me explain what I was about to explain, and then you can tell me if it lines up with what you're thinking. The idea is that like from the user interface perspective, like your front end clients, it would have like a socket or some other way of receiving events from the server. And that would be the sort of like output stream of your API. And then you would also have like an input stream flowing over that same socket. And the idea is that you would send a message that says, hey, I want to create this folder. And then the backend would go off and do its work. Everything would flow through. And then a message would come out of the output stream that says, this folder has been, or this file has been created. And then that would be how you would allow your UI to update. I don't know. Does that line up with what y'all are thinking?
I think so. Yordis, what do you think? Yeah.
Okay. So, and that's like a full event sourcing approach, and that can be a really powerful way of thinking about a system. You get that eventual consistency stuff, as well as you get a UI that works more or less the way that users expect it to, because when a write resolves, it does show up in the UI and it happens in real time. That's not going to look a whole lot different from making a request in the background, having the request resolve, and then come back. The reason that you may not want to go with that approach is that it requires a very different way of thinking about building an application compared to the one that most developers are used to. And then it becomes a sort of like politics and teaching problem. Can you get the rest of your organization on board with this idea? And like, as an example, at my last company, we kind of went for like a sort of splitting the difference between full event sourcing and a more like normal request response cycle. I'll talk more about that in the next slide. But there was concern at my organization that we weren't going to be able to get buy-in from the rest of the organization on full-on event sourcing. So if you start this way, if you start building your system this way and you can get people on board, then this can be a really powerful way of thinking about things, because you're not worried about whether your system is going to be in a consistent state. You know for sure that it's always going to get there. But it comes with, yep. It comes with additional complexity. It comes with different infrastructure. It comes with a different way of thinking about things. So yeah, that one's kind of a lot. I can stop there.
I have a question on this, and maybe you're covering this at like later in the stream, but yeah. Is this pattern something that is repeatable, that could work in like different parts of like a system you're building? So it's not, it's, you're sort of abstracting something like this, like having like an event sourcing type thing that could write to, like your application database and say a permissions database. But as a pattern, can that be used like elsewhere if you're facing like a similar distributed system problem?
Absolutely. And that was why my company went with it, because the question of how do you share state between systems gets to be a really hairy one really quickly. You can do everything in terms of like normal, like RPCs and request response cycles. But the issue is that as the number of as the number of services in your system grows, the number of potential links between systems grows with the square of the number of systems.
Yeah.
And that means that the network traffic inside your system, if you're doing everything with request response, is going to grow roughly as the square of the amount of traffic coming into your system. And that is like a big scaling problem. And so event sourcing is a common thing that people will turn to because rather than having things talk to each other directly to learn about what's going on, you're just putting things onto an event queue, and then listeners can pick up messages as they need to do the things that they need to do, put things out to other event queues. You can still run into issues of like an explosion of events depending on how you've built things and designed things.
Mm-hmm.
But at the very least, you're not necessarily dealing with an explosion in network traffic and an explosion in the number of RPCs that are being made in your system. Yeah, so this is an approach that works generally, and that was something that I wanted to talk about with regards to this, is that like there are reasons that you would use these approaches outside of just making it work with SpiceDB. And ideally, your organization is thinking about this, because part of the reason that you went to use SpiceDB is because you've got a number of services that need to be authorized, and they all need to talk to the same system, so you're already in a microservice context. So ideally, you're using one of these approaches, and the use of SpiceDB with it fits neatly into it.
Yeah.
Yep.
Yeah. Well, yeah. We have a question from Andre. Does this approach work in a situation where I do 3 writes? One folder to my appdb, creator as viewer of the folder to SpiceDB for permissions, creator as viewer to appdb, which is a separate table, for example, for filtering.
So
would that just be another appdb in that is being subscribed to the queue, essentially?
Yeah, I probably, if I was asked to implement that specific logic, I probably would group writing all of the stuff that goes to the appdb in the same transaction in the same handler, because it's just a single thing that happens in response to a single event. So the listener to the subscribe, or the listener for the application database would say, okay, I've seen an event that's to create a folder, to create a file in a folder. So I'm going to write the information about that and write the information about the creator in the same transaction as a response to the same message, and then do the SpiceDB work in a separate one. Does that make sense? Okay.
Yeah, I think so. I think Andre says that as well. Yeah. Okay.
Okay, cool. So this is like the sort of event sourcing adjacents idea. Next thing we're going to talk about is an idea of a durable execution environment. And the idea here is that you use a set of abstractions that lets you pretend that you're writing synchronous code that is running on like just inside your handler, but there's actually stuff that's going on under the covers that takes care of all of the work of making sure that things end up in the places where they should end up. So I've got some example code on the left side. This is from Temporal.io. Temporal is one such durable execution environment. There are others. There's Windmill. There's a whole bunch of others that I can't think of off the top of my head. It's actually a pretty lively space right now. So there's lots of people doing this with different sets of abstractions, different pricing models, all of that kind of stuff. Temporal is just one of the most popular ones, and I found a nice example in their docs, so we're using them as an example. And the idea is that this code looks pretty synchronous. The difference here is that, so, you know, we set up a connection to our client. This is like the details of a payment that's going to go through. And then right here, we do client.workflow.start. And this is where you're dispatching it off to the durable execution environment to do the work. It looks like this is code that lives on my server. Up to implementation details, it may actually technically be code that lives on my server. But conceptually, you can think about this as being pushed off to somewhere else that's doing all of the work for you. And then you're waiting for that workflow to finish and get a result, and then you can do something with that response. So as far as sort of conceptually what it looks like, you've got your application, you've got your databases that you're writing to, and you've got the execution runtime sitting in between them. Again, this isn't necessarily the way that Temporal or any of the other specific implementations works. A lot of their architecture diagrams are a lot more complicated than this, but you can conceptually think about it as a middleman. And the idea is that you dispatch off the work, and then it's taking care of all of the bookkeeping, all of the transaction management. It's effectively acting as a distributed transaction manager. So in the case of our application, like writing files to folders, the idea is that you would dispatch to the execution environment to say, hey, I want to create this folder. And then it's going to take care of the work of, okay, this is what it looks like to write to the application database. Here's what it would look like to roll back that particular transaction. Here's what it would look like to write to SpiceDB. Here's what it would look like to roll back that particular transaction. And then it's going to either work until both of those have completed, or work until both of those have like failed and been rolled back. And it's taking care of making sure that you never end up in a state where you're out of sync. If we go back to our Byzantine generals problem, this would be like if someone was in a balloon over the city and could talk to each of them individually, they're the one that's doing the coordination. It's doing the coordination for you. Yep. Yeah. Notice exactly. That's what I was just about to talk about, is that there's still there's a little bit of a lie here that, this isn't happening synchronously. This is happening in the background. And the issue here is that this is hiding a lot, namely that it's essentially making an RPC to another service that's doing all of the coordination. So not only are you worried about the stability of your SpiceDB and of your application database, but you've also inserted this into the request path, and it's got its own machinery and its own infrastructure needs, and its own tuning. If you have slowdowns in your durable execution runtime, then you're going to have degradations of your service. So like any abstraction, it's useful, and also it can bring problems.
Yeah.
I think the reason that these have been getting more popular recently is that the ergonomics of it are actually pretty nice. You don't have to change how you think about writing a product, because it's doing the work behind the scenes of making sure that everything happens the way that you expect it to happen. It's still manual, because when you're writing these workflows in the language and abstractions of the library, you still need to do all of the bookkeeping. You need to have a definition of this is the forward path, this is the reverse path, this is the retry logic for this particular thing. These are the faults that we're willing to tolerate. These are the faults that we aren't. So you still need to think about all of those things as you are writing those workflows. But then invoking them becomes simpler, because it looks like a normal RPC. You can just make this call, you get the result back, and you can return a result to the client. Yeah. Notice I've never actually worked in one of these, but as I was looking at the documentation, I was like, yeah, I'm sure that would just get to be tedious.
Yeah, I do have a question to folks in the audience watching. Has anyone actually used a durable execution environment like Temporal, in production? I'm very curious. It's new to me as a concept, and I've heard of Temporal, and I've spoken to folks, at conferences and stuff. But yeah, I'm just wondering if anyone actually has. So yeah. The question from Scott here about. I'm not sure what 2PC, 3PC here is referring to. Tanner, would you know?
2-phase commit and 3-phase commit.
Oh, okay.
Okay. Are you saying that that's what's happening under the covers here, or are you asking about that as an approach for solving this particular problem?
2-phase commit, yeah. Okay, so Yordis definitely is used durable execution environments. Cool.
Mm-hmm.
Yeah, as an approach.
Okay. Yeah. So that's something that we have talked about internally. There are certain approaches that seem like they would be nifty that would require having some sort of two-phase commit logic in SpiceDB. Like one thing that sounds nifty is the idea of using a Postgres foreign data wrapper as an interface to SpiceDB, because then for application developers who are interacting with SpiceDB, they don't actually need to use the SpiceDB client. You're using Postgres as the client, and it's sort of just abstracting over everything. And if you make writes in that system, you need to have a two-phase commit protocol exposed for the foreign data wrapper. But that's not something that SpiceDB currently exposes. Part of the reason that we haven't gone that direction yet is because an atomic commit works well enough for most cases. As I mentioned back like earlier in the talk, even if we had a two-phase commit protocol available, there's still something that needs to do the coordination, and you're still like, it doesn't solve the dual write problem by itself. So that, and another part of it is that typically when you're interacting with SpiceDB, you're not like doing a write and then a read then a write in the way that's like in the way that a transaction might happen in a normal RDBMS. Typically, I recognize that there are people who have had that requirements, and like we haven't been able to give a very good answer beyond just like, well, yeah, ensure that like you're using preconditions or you're using the correct consistency when you make the call or make the read call, and you're hoping that nothing shows up afterwards. So it is like, it's in our heads. We haven't gotten there yet. Okay, cool. Yeah. Does that make sense?
Yeah, I think, yeah.
It wasn't a very satisfying answer.
Yeah. Yeah. Scott says thanks.
Okay.
Yeah. Good question, Scott.
Cool. Yeah. So yeah, this is durable execution. It's nice for your developers because it's all fairly familiar and ergonomic. Your SRE team might not like you. The people writing the workflows might not like you, but it's an option. And then finally, we'll talk about a transactional outbox pattern, which is maybe like a sort of medium ground between the two in terms of its eventual consistency, but you still get to pretend that you're just like writing to a single place. And this is actually the approach that my old company used. We had our application talking to the application database. There was some logic in the, like we had a bespoke library that would help with writing events to an outbox table. So when you made a change to an object in the application database, this wrapper would kind of package up a write to the application database that changes a row with a write to the outbox table that includes what changed and the new view of whatever that object was. And then we had some mechanism that picked things up out of the outbox table and moved them into the durable queue. In our case, it was Debezium looking at the outbox table, and then it was writing to Kafka. And then we had a consumer that read off of the queue and then wrote into SpiceDB. And this is nice because like up to the bookkeeping that needs to happen to ensure that you're writing the right things to the outbox table at the right times in a transactional manner, it's relatively simple conceptually for an application developer. They don't need to think too much about like the event sourcing flow. They can just interact with their database in the way that they know how to interact with their database, and then all of the other event logic happens downstream of that. The downside is that you don't necessarily get the ability to know when something has landed in SpiceDB. And for our particular use case, that worked okay because we weren't particularly concerned about the new enemy problem, and we weren't particularly concerned about like how long it would take for a change to be reflected in SpiceDB, because generally the authorization changes happened infrequently enough, and the workflows moved slow enough that it wasn't something that people noticed that much. But we're getting back into that same territory of like, sometimes it's helpful to know when your writes have landed, especially if you're doing like you have like a create flow that immediately wants to go to a detail view and it needs to be able to see what's in the database. So this wasn't something that we solved at my old company, but like an example of how you might approach this. If you're using Z tokens, you could, so like you want a Z token in the application database on the row that you want to review. And the way that that could go is like you write to SpiceDB in this listener, and then either you put a new message onto a new queue, or the listener does the work of going and talking to the application database and writing in the row, like, hey, I just wrote to SpiceDB, and this was the Z token that it gave me back on that write. And then a subsequent read to that can then do something with that. But again, it's still, this is like, it's another view of an eventually consistent system with a different set of trade-offs.
Yeah, I think we have a couple of questions, but I also have a question about this, Dana. So in this pattern, suppose there is, like, say the server goes down or there's a problem in the part between the outbox and the queue, then aren't we stuck with the same problem that we started with, which is in step 3, if something goes wrong, you've written to like one database, but you haven't written to SpiceDB.
So the idea is that when you make a write to your application database into the outbox, this is all happening within a single like Postgres transaction or like RDBMS transaction. So either you're writing to the app database and you're writing to the outbox, or you're not writing to either.
Got it.
Once you have something in the outbox, then theoretically, like if Debezium goes down, that's a problem because then you don't have events flowing through the system. But when Debezium comes back up, it's going to start reading the outbox table at the same place that it left off. And so that message is eventually going to get picked up, put on the queue, and then picked up by the listener. So you're still eventually consistent. You're not worried that at some point at the future, you're going to end up in an inconsistent state, up to making sure that all of the consistency features of your event queue of choice are being properly used.
Yeah.
But yeah, you're not so concerned about that.
Got it. Okay. I think we have a couple of questions from Andre and Yordis, so let's take Andre's first. What if I want to store the object in the backend and still get SpiceDB, Zuki, or Z token? Won't get it from Kafka in the response.
Yep. And that's again, we're kind of back to that same question of like, how do you know that the write has landed? And at my company, we just ignored that entirely because we used minimized latency everywhere. So that's not a satisfying answer.
Well, I guess that answers this part of the question as well. Just
Yeah. So it's something where, like, if you're using React Query on the front end and you make a write and then you make a subsequent request after you've gotten the response from the write, then maybe the network latency involved is less than the latency inside your system for all of those messages to flow through the queue and for you to end up with the Z token back in your application database, such that when you make the subsequent read, you're going to get the new entity back out. And there are other ways that you can work around this. Like if you want to be able to read something that you just created, if your post request returns the representation of the thing that you just created, then you can do work in the front end that just says like, okay, I'm just going to add this thing that was a part of the create flow, or like, store the thing that came back from the creation request. And I know that I can read it as the person who just created it because that's like the semantic of my system. So there are ways of working around like the individual pieces of it. I don't know that I have like a general recommendation for the best way to do it because it's going to depend on like characteristics of the way your user interface works, characteristics of your domain, characteristics of your infrastructure, and the rest of your system. So it depends.
It depends. My favorite answer in tech.
Yeah.
Yeah. Yep. Yeah. Question from Yordis, who says, you end up replicating event sourcing, durable or outbox level of complexity. Still, you don't have an immutable ledger of events.
Are we talking about the transactional outbox pattern, or was this a response? Okay.
Yeah.
An immutable ledger of events. So what do you mean by that?
There's a follow-up. If
you have the outbox outside the outbox, you will say that. Yes, it is technically, it's just another queue. And like the way that we did it at my company, it was like a write-only table that lived in, like, it was another write-only table within the same database. And so it's just like a reflection of a queue that then gets replicated out of that queue. So it was an immutable ledger of events in the sense that we never actually touched that table. It's not an immutable ledger of events in the sense that like it's been written to the thing that we are treating as the queue that is the source of truth. So
Right.
yeah, you're right.
Yeah.
There's some nuance there.
Yeah.
There's some
Yeah.
nuance there.
Yeah. Yeah. Scott says this pattern works great when used as a fallback to regular queue publishing. Interesting. Okay.
Yodis, yes, but then you just move the dual write problem forward, and then you're back to, like, the nice thing about this transactional outbox pattern is that the person writing to the application database can pretend that they don't have to worry about the stuff that's downstream of it. I recognize that, yes, it's just moving the problem around, but in this case, if you're just trying to hide something from other developers, it kind of works okay. And Andre, to your point, in our case, I don't think we ever deleted those. And I think that was just conservatism on the part of my company, that we were more willing to pay for storage than we were willing to tolerate the risk that cleaning up events could lead to unintentional data loss, because we clean up some events that say they've been acknowledged but haven't actually been acknowledged or something like that. Like, our organization was very conservative in that regard, and we had multiple copies of everything. So depends on the organization. Yep, Yodis, exactly. It's a wonder that any software ever works. That's my whole experience of being a developer for 10 years. I'm amazed that any of it works. How do you know it was already sent to the queue? I think that's an implementation detail of the thing that you use to replicate out of your Outbox table. I don't know Debezium all that well. I wasn't required to like know its internals when I was working at the company. So like, I'm not sure if Debezium is holding its own state. Like, I think it might be implemented as a Kafka connector, which means that it's holding the state of like which message it's on outside of the database, rather than like reading a row and then writing to that same row to say like, hey, this has been acknowledged. Yeah, I don't know. I know that it is possible to know. I don't know the specific implementation details.
Got it.
Yeah.
Yeah, we got to have you on then next time. This is interesting. Okay. Yeah.
I'll have a round table.
Yeah, we can have like panel, fireside chat, panel discussion,
Yeah, totally.
Yeah. Sweet. Okay. Yeah, so this is the approach you all finally settled on in your previous company, right, Tanner?
Yeah, and that was a decision that was made sort of like, I wasn't involved in that decision. It was made by some architect somewhere before I got there. It worked okay. There were definitely some pain points. Like, one thing that was just like an eternal pain in my butt was that the way that we used Kafka should have allowed for compaction, because we were doing this notion of event carried state transfer, where the idea was that a business event would come through and then you would see the new state of the object. And theoretically, that last state is kind of the only thing that your system really needs to care about in most cases. Like, you're not actually concerned about how it got there. And so theoretically, we would have been able to compact events according to a key of, like, we only need the most recent events for a particular object. But we never actually did that. And so what that meant was that anytime, like, the other thing too is that seeking to a particular place in the queue in Kafka is not really a thing that you can do easily, which meant that anytime that we screwed up something or like needed to rethink the logic of how we listen to events that go into SpiceDB, like anytime that we made a breaking change to a consumer, we had to go and reconsume the entire queue from the beginning. And that would take like in some cases it took us days, and it was in a lot of cases like kind of wasted work. Like it didn't really seem like it was necessary. But you know, this is to some degree that's like implementation details. That's the particular queue that we chose to use in the particular way that we chose to use it. Let's see. What if we write to AppDB and Outbox and SpiceDB at the same time? We can use Outbox. Yep, that's true. That is, I would say that's kind of a hybrid approach between the transactional Outbox pattern and the out of band consistency checking. And it's, I don't think there's anything wrong with it. I think it's more that like you're making a set of trade-offs around, yeah, exactly, Scott. You're making a set of trade-offs between complexity and like consistency. That you like the out of band consistency checking can become a problem for all of the reasons that we talked about in that case. And like what you're talking about is essentially optimistic updates, but like instead of it being in the UI, it's like down the level of your API. And that actually, yeah, now that I think about it, that might be a sane approach, especially because the like you have idempotent updates available to you in SpiceDB. When you write a relation, you can write it using a touch semantic, and if you do a creation on it and words, you can do a creation in a way that like if the thing already exists, that's fine. You're just touching it, and then deletes are also idempotent. And so theoretically, if you do the dual write in your handler, and then you also have a queue that's coming in behind and making that same set of updates in the same order, then you should come to the same conclusion eventually. In the meantime, there might be a little bit of thrashing and inconsistency depending on the order in which things are applied, especially if you have like a lot of write traffic coming in and it's being applied from like different application nodes. But as long as you can as long as you can guarantee an ordering of events that is sane for your use case, then that seems like it would make sense.
Nice.
Yeah. Yeah, so anyway, which one to choose? We talked a little bit about some of this, and you know, the broad answer is it depends, but there are some things that you might want to think about. One is the sensitivity of your data and the sensitivity of your users. If you have hard compliance requirements, that's probably going to push you in one direction or another. If the application is one where users are going to complain loudly if something doesn't show up in the way that they expect it to when they expect it to, versus like a system where like, it's good enough, it'll be fine. So like those are two things that are going to feed into the decision. Another one is existing infrastructure. If you already have characteristics of your system that would push you in one direction or another, just continuing to build in that direction could be a reason to move in that direction. Like I said, all of the sort of eventual consistency options that I was talking about are roughly equivalent. They're making different sets of trade-offs and requiring you to do different kinds of work, but all of them, you know that at some point in the future, your system is going to end up in a consistent state. Your UI architecture and UI flows can feed into this. Like if you want to do event sourcing, but the API server that you're using doesn't actually support WebSockets. Like, you know, if you're using Django, getting Django to work with WebSockets is a complete hairball. Would not recommend. So if you're using Django, you don't see yourself moving off of Django, then that might restrict you from being able to use an event sourcing approach where events are being pushed to the front end through a socket. And then like also this question of like, what are your UI flows? What are your UI requirements? Do you need to be able to read your writes? What does that look like? That can be another constraint on the system. And then we talked about this a little bit, but the appetite of your application developers is a part of it. Like I was on a platform team, and it was like a sibling platform team that was doing all of the work of setting up this transactional outbox pattern. And I know that a big thing that they talked about when they were coming up, like on that platform team, when they were coming up with the approaches that we used in my company, was knowing that there were like probably half of the developers at the company were just like, I don't care. I really don't care about this, and I really don't want to learn about it. Just like, give me the thing that's going to work. So, if you have developers like that, where it's going to be really hard to get them to think in terms of event sourcing, or like if there's sort of like institutional inertia that's going to be hard to overcome, then using an approach that's closer to what's already in your system can be valuable. Like, there are organizational and political considerations here, even when there are technical reasons not to go the direction that that's pushing you. So all of that to say, it's a hard problem. And there's no one good way to solve it.
Yeah. One, I think it's great that you just mentioned the fact that this could be like a personnel and like a political and challenge, because a lot of working in teams and software development does boil down to things like that, right? Where you have maybe like a technical path forward, but there are other things that have these roadblocks that are not exactly technical, but they still exist. So you have to work your way around it.
Yeah. I like to say that all problems are people problems at the end of the day.
Yeah. That is true. Yeah.
But yeah.
Yeah. I think there was some conversation about Scott asking if, that hybrid approach opens up like the new enemy problem, because you have, two systems that are upserting a relationship that could end up creating an app, deleting an app, creating again, etc. But I think Andres replied, yeah.
Yep. Yeah. And you're right. Like, the sort of specifics of the implementation details are going to need to consider those constraints. Like, if you're not particularly worried about the new enemy problem, like we were at my last company, then just going and like having a single unidirectional flow, it was fine for us. It's not going to be fine for every company and every use case.
Sweet.
Yeah. Cool.
Yeah. For folks interested, so Tanner's also written a blog post describing a lot of this. If you want to revisit it, or if you just want to send a blog post to folks, put it in the chat, and feel free to read it later. And yeah, any last thoughts, Tanner? And before that, maybe I'll just thank everyone for keeping this super engaged. So Andre's got Fantasy Star 4 Grand Cross, but also Yordis, Evan, etc. Thanks for watching. It was super fun. Yeah. Tanner, last thoughts?
Nothing off the top of my head. Good luck, I guess.
Yeah, good luck solving this. I was just going to quickly shout out that if you are using SpiceDB, and I'm guessing a bunch of y'all are, Tanner's worked on a new feature that's in preview right now called composable schemas. We'll be doing a stream about that very shortly, but it's in preview, so go try it out, give us your feedback, and we'd love to hear from you about it. It's on our GitHub. You'll find there. Alex says wrong channel got in there. No problem, Alex. Thanks for joining the stream. Yeah. Got to switch the YouTube account, but yeah. Yeah, and Andre says do queue connector from SpiceDB. Good feedback, Andre. We'll add it to our queue about future live streams. Yeah.
Yep. That's been on my list of something that I want to do, like either a Bento implementation or a Kafka connector implementation. Like, we know that this is a way that people are using the system, so we want to support that. It's in the works.
Okay.
I'll put it that way.
Yeah. Nice. And yeah, so again, for folks joining us for the first time, we stream every 2 weeks. So 2 weeks from now, I'll be doing a stream with Veronica. We're talking about load testing and some performance tests that she worked on for SpiceDB. It's going to be fun. So check that out. She's awesome as well. So, check that out. And yeah, again, thanks everyone for watching. Thank you, Tanner. That was super informative. I learned a lot as well. And we will see you all in 2 weeks.
Cool. Thanks, everybody.
Bye.